Welcome back, learners. So now jumping to our first concept, whereby we're going to be looking at the components of an electric circuit. And remember, we are specifically looking at a series circuit. So we need to start by identifying and also try to understand what a series circuit is. So we need to know that in a series circuit, all the components, so everything that we find connected in a circuit, especially in series, all the components in a series circuit except for voltmeters, they are connected in series. So that means they are connected one after the other. They are connected in line, as it says there. So that means if they are connected in series, there's only one path for the current to flow. So because they're connected in line one after the other, current has no choice but to follow only that particular path which has been identified for it. Furthermore, the cells that we find in a circuit, they can also be connected in series. And how can then the cells be connected in series? First of all, we are going to connect one or more cells in series in a circuit by connecting a negative terminal of one cell to a positive terminal of another cell. Now remember, when we are connecting the cells or when we're drawing the cells in a circuit diagram, we are using this notation to say that the longer line is going to be your positive terminal and the shorter one is going to be your negative terminal. So what we are saying is, if your cells are connected in series, we have a negative terminal that is going to be connected to a positive terminal. So this is what we have here. Our negative terminal is connected to our positive terminal. Then, we're also going to now have another cell, because if we have more than one cell, remember we are forming a battery. So if you have more than one cell, a negative will always be connected to a positive. Then, if in a case of having two cells, we have our negative connected with our positive, then this positive will be connected to a negative. And then this negative is going to always be connected to a positive. So they alternate. We kind of have a case whereby we have a negative cell, we have a negative cell or a negative terminal connected to another negative terminal. So if we are connecting our cells in series, one negative must be connected to another positive, and then that positive must be connected to a different negative, and then that different negative to a different positive. So depending on the number of cells that we have in a circuit, we can now connect as many as we want, but then in that particular order. That negative is going to be connected to a positive, and so forth and so forth. So we are saying that when we have more than one cells in series in a circuit, we're going to connect a negative terminal to the positive terminal of a second cell, and then connecting this cell's negative terminals to the positive terminal of a third cell. As we are saying, depending on how many we have, we can connect as many as we want. So we are saying on this picture here that a series circuit, very important to note that a series circuit is one with now that only allows current to pass in just one particular pathway, from the negative terminal to the positive terminal. So as your current is moving through these terminals from negative to positive, it is only going to follow these wires going across and then back to the cell, and then also in that motion all around up until the battery runs out. Now, what do we then find in a series circuit, or rather, what do you find in an electrical cell? We first start by finding an ammeter. So an ammeter is a measuring device, so we use an ammeter to measure current. So an ammeter is a measuring device used to measure the electric current. So now this electric current is going to be measured in a circuit, as we know, and it is always connected in series. So we're always connecting our ammeter in a circuit in series. And we should know that the current is measured in amperes, which is given by this notation of capital letter W. So in a series circuit, or in any circuit that you may find, you will see that an ammeter was connected when you see this notation of an A. Whenever you see in a drawing an A that is being drawn in a circuit, know that an ammeter is connected in that particular circuit. What else we find in a circuit? We also find a voltmeter. So now, a voltmeter, that's now a measuring device that is used to measure voltage. So the voltage is measured by the voltmeter, as we are saying. And then the unit for potential difference, or rather the unit for this voltage, it is going to be our V. our volts. So we're measuring the voltage in volts and the unit is V. Much like the current is measured in amperes, the unit for current is A. In this case, voltage is measured in volts and then the unit is going to be V. So the voltmeter has a very higher internal resistance. Remember, resistance, that's now the tendency of a conductor to resist the movement or the flow of current. So because it has a higher resistance, it must be connected in parallel. And then it is going to be connected in parallel with the components that you are trying to measure. Now, you therefore need to connect it to 2 points that you are finding in a circuit. So when we are measuring our potential difference, or rather, when we are connecting our potential difference, it must be connected across 2 points. And it must always be connected in parallel, as we have said. It cannot be connected in series because we're saying that the voltmeter has a high internal resistance. And because of that, it is going to be connected in parallel. So the voltmeter calculates the potential difference between 2 points. So the potential difference that you're going to be measuring between these 2 points is going to be registered on our device, our voltmeter. So remember, we are using the potential difference to measure the voltage, and it is measured in volts, and the unit is V. We also find a resistor in an electric circuit. So a resistor is a conducting material selected to control, remember resistor, it is to control the current or to provide useful energy transfer, such as in bulbs, rheostats, motors, light-sensitive diodes, and light-emitting diodes. So this resistor, it is used to control the flow of current, and then also we are saying we are using a resistor for its usefulness. Now the bulbs that you are using at home, those are actually an example of a resistor. So we're using those bulbs at home because we're trying to gain light from them. So they are useful in a sense that they are giving us light, as we are saying that we are using these resistors such as bulbs, the rheostats, motors, and the likes that you are given here. So we're using them because of their usefulness, what they can provide for us. However, remember, those in an electric circuit, they are used to control or to regulate the current flow from one point to the other. So these resistors are set to resist the movement of electrons, as we have said. Now these electrons, that's now when the electrons are moving from one point to the other. We call that our current flow. So the resistors are going to influence the electric current in a circuit. That then means the more current or the more resistors we add in a circuit, we are influencing the current strength. So it is going to control the current strength even more. So the more we add, that's now more of the current will be controlled by those particular resistors that we are adding in a circuit. So this resistance or the resistor, it has resistance that's measured in ohms, and it has a symbol of this omega. So this is the symbol for resistance, and then it is measured in ohms. Remember, a voltage is measured in volts with the symbol V. Ammeter measures current, it's measured in amperes, and then it has a symbol A, whereas now our resistance is measured in ohms with this symbol being the omega. So all of those three variables, they have a certain relationship that we're going to be talking about. So an adjustable resistor is called a rheostat. If you are able to adjust your resistance, or if you're able to adjust your resistance in your resistor, that particular resistor will be given the name of a rheostat. So now let's summarize what a resistor is and what does it do in a circuit. So a resistor, we are saying that as we adding more resistors in a circuit, in particular in a series circuit, the total resistance of the circuit is going to increase. When we add more resistors in a circuit, in series rather, we are going to be now increasing the resistance of the circuit. Furthermore, when the total resistance increases, so as we keep on adding those resistors in series, we are increasing the resistance, and when that happens, the current strength is going to decrease. So in other words, in series or in a series circuit, the more resistors we have, the current strength is going to be decreasing in that particular circuit. Furthermore, in a series circuit, there's only one pathway for the electrons to move through. So in a series circuit, the electrons, or rather the current strength, or the current rather, it is going to be moving in one pathway from one point to the other, from the negative terminal through the wires and back to the positive terminal. And then lastly, the current strength is the same everywhere in that pathway. So on this particular series diagram that we have, wherever we decide to measure our current strength, it is going to be the same throughout. If we measure it between this point and that point, it is going to be the same as whether we are measuring it between this point and that point. So at whichever point we choose to measure our current strength, it is always going to be the same in series because of the resistors that we have and the way in which that path is provided to the electrons to move in that particular path. So now, before going to our next concept, we're just going to go for a short break and I will see you just after this.